Hello and welcome. This is Lino Tadros from the Training Boss, and in this video we are going to demonstrate how to deal with drag in prompt flow by bringing in data from outside using a kind of file like a PDF or a Word document or an Excel spreadsheet. How do you augment actually the LLM with this type of information? So let's go ahead and get started. The first thing you want to do is to go to ai.azure.com. That is your Azure AI Studio. And currently I don't have any projects or any hubs or anything like that. I'm going to create a brand new one. So let's go ahead and create a new project. And in this project, we'll give it a name. I'm going to go ahead and call it Lino, for instance, and we'll give it today's date. There you go, 0706. And then for the hub, I don't have one. So I'm going to go ahead and create one as well. We can give it a hub name. You can give it whatever name you want. I'm going to use my subscription. I'm going to choose a name for my resource group where I would like to create that in the portal. I'm going to create this one in the east of the US. I'm going to also create an Azure AI service. I will leave the name as is, as fine. But one extra thing I want to do, because I'm going to use embedding and vectorization, so I will need an Azure AI Search to serve as my vectorization database. So let's go ahead and create one of those. I'm going to call it Lino-AI Search. Oops, there you go. How about that? And we'll say create. All right, now I'm going to go ahead and validate all these names that they're available and everything is good. We'll say next. These are the resources that will be created for me in a resource group. I'm going to go ahead and create the project. And it usually takes about a minute, minute and a half max to create all these resources in my subscription under the Azure portal. So I'll come back after all of them are in the green and we got ourselves a brand new project created in Azure AI Studio. And there you go. After a couple of minutes, all my 6 different resources got created. I will end up in the Azure AI Studio with my project called Lino 0706, and it has no resource type for right now. That's great. So let's go ahead and create a prompt flow, but this one I would like to actually accept the RAG model to be able to augment everything with my own PDFs or Word documents or Excel spreadsheets and so on. So I'm going to go to prompt flow here under tools on the left side. And we'll go ahead and create our first flow. We'll say create. And under the filtering in here, I want to create a chat flow. And notice there is one called multi-round question and answer on your own data. So let's go ahead and clone this one instead of starting from scratch. It will give you a pretty good template to start with. We'll say clone this guy. Here I can actually give it a folder name. You can call it whatever you want, of course. I'm going to leave the same name the system actually suggested. We'll say clone. And that will take another minute or so, so I'll come back as soon as the new prompt flow got created. And voila, the flow got created. And as you can see here on the right side, the graph got created. There's a lot more items in here than the usual standard hello world. This one has, of course, the inputs and the outputs at the end. But in the middle, we have an LLM, which is the modified query with history, the one that will actually give it a prompt and be able to bring in the history. Then I have a lookup, which is very interesting, of course. This is the one that I'm going to be taking my questions and embedding and vectorizing it to see what the similarities are available in the database. I still did not tell the system what are the documents that I want or anything like that. But before I even work on anything inside of my flow, one of the things I did not do yet is to deploy a model. So let's go to deployments all the way at the left. On the bottom here under components, we'll say deployments. Oh, let me go ahead and save this first. So I'm going to save it just to make sure everything is available for me when I get back to it. Oh, it's still working on saving. Let's give it another few seconds to finish the save. Okay, we'll go to deployment. And I don't have any models deployed at all, so I'm going to create one. You get to choose from tons of different models, of course, available for you to deploy. GPT-4o, 4, DALL-E if you're using images, 3.5 Turbo if you're testing some things and you wanted to make it real cheap. There are even embedding models as well, not just the LLM models that you want to go for. So let's go ahead and, for instance, start with a GPT-4. I'm going to click on this guy. We'll say confirm. And again, that will take probably another minute or so to create that. So no code is available to deploy this model version and deployment type. Try selecting a different Azure OpenAI or AI service resources. Whenever you get this kind of warning or an error, that's probably you have other resources in the system that are using this. And the part that a lot of people do not realize, you might have actually deleted these OpenAI resources, so you don't have them anymore, but they're still complaining that you don't have enough quota. And the reason for that is there is a retention, so you need to go ahead and purge all the deleted values, otherwise they will still count until the purge goes away. So let me go ahead and take care of that. One of the ways you can do that, I'm going to go to my portal. Let me refresh this. There is the new Arduino AI group that I just created from inside of Azure AI Studio. Let's click on that. These are all the resources in here. I would like to go ahead and click on, maybe choose OpenAI, Azure OpenAI. And one of the best things that you can do is to say manage deleted resources. Let's click on that and see if there is anything in here that has not been deleted. Actually, there isn't. There is nothing in here that is actually keeping us from using our quota. So I'm going to say close that. So obviously it was a timing issue between deleting from before and right now. So I'm going to go ahead and cancel this, and let's go ahead and do it one more time. It was just a timing issue because I just deleted a previous installation. We'll say GPT-4, confirm, and still not happy with it. All right, I'm not going to fight it. If it doesn't like me for GPT-4, let's go ahead and deploy maybe 4.0. Let's say, let's go ahead and deploy this guy. Let's see if we get the same error. No, it doesn't look like it. It looks like we're going to be much happier with GPT 4.0. Sometimes, again, based on previews and the latest and greatest, you're going to get these glitches. It's not a big deal. So I'm going to use GPT 4.0, the model version in here. That's the latest. I'm going to use that one. And it will be a standard deployment. I'm going to leave the name for the connected Azure OpenAI resource as is. I'm going to actually move this a little bit to 40 because I'm going to use it for a lot of different things. So maybe having a 40,000 TPMs in here will be a much better thing for a token per minute for the rate on the whole thing. All right, so I'm going to leave everything the same. We'll say deploy. And now we go ahead and wait a few seconds until the GPT 4.0 has been deployed for us and we're ready to go. So if I go back to deployments, you will notice that my GPT 4.0 has been deployed. I can go back and create another deployment for like embedded ADA 002 or embedded ADA 003 for the portion where I'm going to be doing modeling against the embedding portion, not the LLM portion. But you don't really need to do that in Azure AI Studio. Whenever you need to vectorize a document or a bunch of documents, if you don't have an embedding, it will automatically create an embedding 002, ADA 002 for you. But again, if you feel more comfortable creating one so that you can choose the one that you created instead of letting the system create one for you, you are more than welcome to do that as well. All right, what else can I do in here? Well, I would like to do the Benihana effect on my documents. So first of all, I'm going to bring you a document that I downloaded from the internet. That is a PDF that, as you can see on the right side, it has 33 pages in it. Just a PDF that explains how to use and how to set up Microsoft Surface Pro 4 for Windows 10. So if you take a look in here, for instance, it knows in this document how to set it up, how to charge it, how to power and charge for the cord itself, how to browsing tips, account sign in, all of these things in here. Plus also, if you go down in the document, there are some images with the information around the image itself. All that stuff I would like to bring in, embed and vectorize, and start asking questions that will be limited to the information inside of these 33 different pages itself. So great. Let me go ahead and show you how we're going to do that. So under components here on the left, there is a tab here called indexes. Let's click on that. It's empty right now. So I'm going to create my first index. And it will ask me what is the data source for that. You have a lot of different choices. You could already have a vectorization database. You could actually create an Azure AI Search, which acts as a vectorization database. You can actually use some data that you uploaded into the Azure AI Studio itself. See, there is data component in here. It could be in a blob storage in Azure. It could be a storage URL that you're bringing from somewhere else. In my case in here, I have that 33-page PDF available on my machine itself. So I'm going to upload the files. And notice it says files. You don't have to upload just one file. For this sample, I'm going to upload the 33-page PDF, but you can imagine you have 10, 100, 1,000 different documents that you'd like to vectorize. Some companies, we would like to have a significant amount of PDFs like invoices that they would like to get the totals and everything for specific companies and so on. You can do that. So I'm going to go to the uploads in here. I can upload it files, or I can upload from a folder. So if you have a folder which has like 500 different PDFs and Word documents and others, you can actually point to that folder and it will load everything inside of it as well. So let's go ahead and upload this file. I'm going to go to my downloads folder. Let's see, there it is, Surface Pro. It's about 1.25 megabyte. It's a very small file. You will notice it will load that. And right now it's going into the storage account that I created when I created the project inside of Azure AI Studio. Great, let's say next. And now it's asking me a very important question. It's going to ask me select to the Azure AI Search service. Remember that got created for me automatically in the beginning when I chose to create an Azure AI Search, if you remember. That means instead of creating a brand new one, I'm going to say connect in here. And notice this is the one that got created when I created the project for the Azure AI Search. So I'm going to say add this connection. And now it actually added the connection, and it will create an index name. It will have a weird name. It always come up with some funny names. If you don't like that, delete this and create your own. I'm going to leave it as is now, alrighty? And we will actually choose the virtual machine that will actually do the work to be auto-selected. If you are picky and you'd like to find out exactly how powerful as far as vCores and memory and storage and all that stuff the VM is, you're more than welcome to create a compute power to do that, or auto-select, let the system for Azure AI Studio do it for you automatically. I'm going to say next. And now the embedding, notice here in the comment says, if you do not have a model for the embedding for ADA 002, which I don't, it will create one for you. Of course, if you would have gone to deployment and created your own, you would have been able to pick it straight from here as well. But if it's not going to find one in your deployments, it will just go ahead and create one for you, which is fine with me. We'll say next. And now we'll give it a few seconds. We'll say create, and then it will start the job. The job here might take between 3 to 5 minutes. What's it doing right now, folks, is definitely doing the Benihana effect. That means it's chunking and it's overlapping and ingesting the data first, of course, and then it's doing embedding, and then it's doing vectorization to put the index. So there is a lot of things in here. So you will notice on the right side, the status, there are 3 different steps that it has to go through. The first one, of course, is ingesting the PDF file from the storage account. The second one is the Benihana, right? Chunking, creating different chunks out of the 33 pages and overlapping between each chunk so that the last maybe 50 or 100 characters of each chunk is repeated in the second chunk so it doesn't lose the meaning or the purpose of these chunks. And then after it does that, it will do the embedding, all right? So it will take every single chunk and it will create based on our embedding model, which is the ADA 002, which has 1,536 different axes, okay? So it will create 1,536 different floats, numbers, that represent that chunk, and it will place them inside of that sphere of knowledge, of the knowledge management that we are creating, so that we can actually get things very similar. It doesn't have to be exact, so it gets a lot smarter about that as well. Of course, right now we're going to be patient for 3 to 5 minutes. It will go from the first step to the second step of creating the index, and then it will be done. We are still, as you can see, in ai.azure.com. If you would like to see what's going on behind the scene, you can click on this job detail, all right? And then that will take you to the ml.azure.com, the machine learning studio itself, to go deep and find exactly the chunking, the overlapping, and the embedding, and you will go a lot deeper. This Azure AI Studio is mainly for application developers. If you are a data scientist or a data engineer and you need to go much deeper into what's going on behind the scene, open that inside of your machine learning studio and you will be able to follow exactly what's happening in there. By clicking on this job detail, will take us there if you would like. I'm going to leave it here for the next maybe 2-3 minutes to finish up all the steps from 1 to 3. And whenever all of them are successful, I'll come back and hopefully we can actually start with our flow. And like I said, while we're waiting for this, I can show you what the machine learning studio is doing. So if you click on this job details, notice we are in ai.azure.com for application developers. If I click on the job detail, it will open up ml.azure.com and it will show you deeper as a data scientist or a data engineer what exactly is going on the inside. So let's open this up, wait for it for a second to load. And there it is, you see, now we're seeing the vector index data set, the chunking and the overlapping is taken care of, and then it will move after this is green, it will move for the embedding, and finally it will register the vector index and it will return it back so that it can be seen by the Azure AI Studio itself, all right? So I'm gonna close this guy down. See, it's in the blue, that means it found a VM finally to do the job. So now it will go much faster, hopefully. Now, if I close this and go back in here, you'll notice, yep, this is now doing the Benihana effect. Is the cracking and chunking and overlapping is going on. So I'll come back after this piece is done. All right, and after a few minutes, the first step has been successful. And now we're creating the Azure AI Search index itself. And we'll come back after this step is done as well. And the second step is completed as well. And now it's the final step, registering the index in the Azure AI Search, and we'll be done with the ragging actually of that specific step to bring in the documents and chunk it, embed it, and vectorize it for the prompt flow. And after a few minutes, we are all done. All three steps are in the green, successful, and we got ourselves indexed and ready to go for our prompt flow. Great, let's go ahead now and open up the prompt flow again. That is the prompt flow we created earlier in this video. I'm gonna open it up one more time. And in the graph, there are some things I wanna make sure that I have it taken care of. First of all, the modify query with history in here for the LLM. I need to connect to the correct connection. Remember, we created a GPT-4o. Let's go ahead and choose that. That is the resource for it. I'm going to use the GPT-4o. There it is. I'm going to maybe choose maximum tokens, 1,000 tokens for that. That's fine with me. And that's all I need to get this piece done. Let's go ahead and save that. And now we're going to go to one of the most important steps, which is the lookup itself, straight from our Azure AI Search. So I'm going to click on the lookup in here. And the first part is the machine learning index content. It's a string. Where is it going to be coming from? So I'm going to click in here. And the index type, there are a lot of different types available. We'll have to wait a little bit. It's brand new, so we'll have to wait a few minutes until this actually comes up. So I'm going to not do anything. I'm just going to leave it alone, and I will come back here in a few minutes once everything has been propagated as far as resources in the system. Let's give it another shot. All right, I think it needs a runtime to be running for us to do that step. Let me cancel this. Yes, you see, if I would have actually created a VM with a specification regarding the vCores and the memory and so on, I could have started, or I can tell the system just to start an automatic compute session to be able to use all of these things. Otherwise, there is no machine to be able to execute these steps. So I'm going to start the compute session. It usually takes about 10 to 15 seconds for the compute session to start. So I'll come back as soon as this tells me that it's ready to go. And indeed, it took about 30 seconds, not 10 or 15, but that's okay. Now the compute session is running. Let's go back to our lookup, and I'm going to click in here again. And hopefully this time it will use the machine to be able to show me what's available for me to pick from. And it does. The one I'm interested in is not going to be a direct Azure AI Search. I don't want to start a new one. There is a FICE database that you can use. There's ML index file from Path if you have to. In my case, I'm going to use the registered index. I already registered, so we'll click on that. And then the ML index asset ID, that will be, let me open it up. It will be the name, the weird name, remember, of the index that got created for me when I created that. I'm going to be pointing to this, and I would say save. Once I do that, almost all the inputs for my index lookup is available, except the query type. The query type could be multiple things. It could be keyword, it could be semantic, it could be vector. It could be a hybrid between vector and keyword, which is actually the strongest one in all of them. It's the best of all worlds. Or it could be a hybrid and semantic as well. In my case, I'm going to use the vector database that we just created for the index and keyword as well. And we'll be done with this step. We'll say save. So from now on, whenever I ask a question, that question will be embedded and vectorized and sent to that sphere of knowledge for the knowledge management, where it has the entire 33-page document already indexed inside of there to be able to get me the closest to what I'm asking about inside of there. All right. Then we have the generate prompt context, and that piece is in Python. Again, it got generated for me automatically. It knows how to generate the prompt context, go get the chunks that are relevant that came out of the lookup, and being able to add that to the prompt. So it's taking really the chunks that came back out of the search and adding it to the prompt as a content as well. Finally, there's the prompt variants. Automatically, the template that we chose create 3 different variants so that you can actually later on do what we call prompt flow evaluation to find out which prompt gave you the best answer, so that you can actually really test your prompts and find out which one works best with your documents, with your knowledge management, and so on. There are 3 automatically got created for me. I really don't need all 3. I'm going to actually show the variants. I'm going to delete 2 of them. I'm going to keep it as simple as possible. So I'm going to leave this variant 0 with that is my system prompt. I'm going to go there to variant 1. I'm going to delete this one. I don't need it. You can leave it. In future videos, we'll probably show you how to do the evaluation on multiple prompts and variants and so on. But for right now, let me delete also number 2. So now I'm going to have only one prompt that will go in. That's it. The final piece is the chat with the context itself. This is the LLM piece. I just need to connect to the GPT 4.0. So we'll say use this connection. And the deployment name is called the GPT 4.0, if you remember, still 1,000 tokens. And I'll be passing exactly what was given to me from the prompt as the prompt text. This is it. I'm going to go ahead and say save. And if I've done my job right, I should be able now to start a chat session and ask about things only available inside of these 33 pages. But remember, the good news is I'm not sending the entire 33 pages to the LLM. That will take a lot of tokens, alrighty? What I'm doing is actually I'm doing a lookup first, and it will bring me back the chunks that are relative to what I'm asking. And these are the only chunks that will end up going to the LLM. So I'm saving definitely on tokens, and also I'm getting similarities. So even if I don't use the exact wording, it will still find the closest thing possible to the meaning of what I'm asking. It will still be able to answer. So it gets a lot smarter and a lot cheaper using RAG that way. All right, let's go ahead and click on chat. And again, this is available already in the previous template that I downloaded or cloned. But I'm going to come in here and I'd like to ask a completely different question. It's like how to handle the power cord. The power cord in Surface Pro 4. Okay, let's ask this question because I know that there is a section in there that's talking about the power cord and how you should deal with it. So let's ask that question. And if I've done my job right, I also ask for citation. It means you need to tell me where or which document proves that this answer is coming from, because I want exact explainability as well. So right now it's actually sending, first of all, it did the lookup into the index itself, and then it's sending that chunk to the LLM, and the LLM is actually making the decision to reply. And there it is: to handle the power cord of your Surface Pro 4, avoid twisting or pinching, don't wrap your power cord, inspect your power cord, and all that stuff. And at the end, notice the source, that's called the citation, is telling you which document that came from. Well, we are actually lucky we have only one document. But can you imagine having like 100 or 1,000 documents? And when I ask a question for proof, I want you to tell me which document did you find this answer in. So for banks and for healthcare and for a lot of different things, it could be extremely important because I want exact answer. I don't want hallucinations, and I don't want you to come up with answers. I want you to get it directly from what I'm asking about. Not only that, but one of the things that I love in Azure AI Studio as well is that the viewing the trace. If I click on the view trace, I can see all the steps. How did the system come up with that? So you see here in the flow, I can see the input and the output. I can see even the raw JSON, which could be important if I'm writing my own application and I'd like to make REST API calls. I know exactly what to expect as far as the JSON coming back based on every single step. The function, for instance, for the modifying of the query and the history, how it worked. I can see the open chat API, what comes from the system, what comes from the user, what comes from the assistant. All of it would be here. I can see the raw JSON as well. I can see the lookup, what happens, how did I actually get to the chunks by making the query into the embedding and the vectorization of the question itself to fit into the sphere. I can see all the stuff in here. And you can keep going down, see how the embedding have with the question, how did we do the retrieval, all right? How did we get to the point where we passing the variant, the prompt variant directly into the LLM, and how at the end we got the answer from the OpenAI chat to find out what to do with the power cord, for instance, in a Surface Pro 4. All of these, you can see if there are some exceptions, some logs. So I can come in here and see if there is an exception. You'll see what the exception was. This could be very, very useful for debugging as well, right inside of here for an application developer. And this is all I really wanted to show you, how easy it is. I know it took some time, but to set it up is just a few steps. First, you will index your documents. You will put it in an Azure AI Index or FICE or Pinecone or whatever vectorization database you'd like. And then you will set up the different nodes from LLM to Python. And most of the work for RAG is already implemented using these cloned prompt flows that you can see. And then you can start asking questions about it, and you can see the value of having something like this coming in from your own documents with citation and everything else. I hope you enjoyed the video. And if you did, please like and subscribe. And I look forward to creating more videos on Azure AI Studio and Prompt Flow in the future. Thank you.